In this module, we want to take a look at functions. Functions help us describe how two sets of data are related to one another. And it's going to help me show how one quantity might be determining the other quantity and help me make predictions. We call those models. All right, so we're going to look at a wide variety. We're going to get some basic language, some descriptions. We're going to see some basic functions and their related equations. Now, it's important to recognize that functions can be described in various ways. I can make a statement, Joe makes $10 per hour. I'm telling you how two things are related. I can make a table and pick out some specific points. So 0 hours, 0 pay. 1 hour worked, $10 pay. 2 hours worked, he's going to get $20, and so on. To see what kind of pattern I might have, it's very helpful to make a graph or a visual representation of the information. In this case, I'm choosing the number of hours as my input. That's my independent variable, and I'm going to put that on the horizontal axis. My output is dependent on that. How much pay he gets is dependent on the number of hours, so that goes on our vertical axis. When we plot those points that are in my table, we see that they line up perfectly and make a straight line. So we're going to call this a linear function because that's the shape of the graph. I can also represent this as an equation, an algebraic equation. P is equal to 10 times H. That allows me to say, well, after 40 hours, how much is he going to make? Oh, here's my formula, multiply by 10. Right, so are there other types? Of course there are. So here's another example. A ball is thrown upward from a height of 15 feet with an initial velocity of 70 feet per second. Well, with some fancy equipment, we could actually calculate the height of this ball at various times. And that's what I have in my chart here. So initial time 0, where I start, I'm at 15 feet. After 1 second, it's up to 69 feet. Then at 2 seconds, it's at 91 feet. But by 3 seconds, we're back down to 81. And at 4 seconds, we're all the way down to 39 feet. So it initially increases, it hits a high point called a maximum, and then decreases. When we see a shape like that, we know there's a different type of relationship between the input time and the output height. In fact, it's what we call a quadratic relationship. So I have this formula at the bottom, h is equal to negative 16 times time squared plus 70 times the time plus 15. That's called a quadratic equation and gives us the shape of a parabola. One more. In mitosis, which I'm sure you studied in biology, we learned that a cell divides into two identical cells, and then those two cells divide into two cells, and then they keep dividing likewise. So I'm going to start with generation 0, 1 cell. 1 generation or split, I'm up to 2 cells. Those 2 cells in the second generation become 4 cells. By the third generation, I'm up to 8 cells, and we just keep going like that. This time, if we plot those points, we need to really have a high vertical axis because this grows very rapidly. It's a different type of increase, and it's no decrease. It just keeps increasing. This is going to be a different type of equation then. In fact, we call this one an exponential equation, and I've got it written down here. C is equal to 2 raised to, as an exponent, the g, meaning the number of generations. Okay, so we want to be able to do the following when we finish this module. We want to be able to graph functions. So if I'm given a relationship, can I find some specific ordered pairs and then put them on a graph? Because I want to be able to look at that graph, and then I want to be able to describe that graph. Is it increasing, decreasing? Is it constantly going up at the same rate? Is it starting off slow and then really getting big fast? What's going on? What's different about these graphs? Because that will enable us to come up with models that we're going to be working with down the road. We also want to be able to recognize and use transformations. So what if we tweak our equation just a little bit? How is that going to change my graph? Or if my graph changes a little bit, what do I need to do differently to my formula to make it line up with the picture? All right, and finally, we're going to do some word problems, those applications. That's really the heart of mathematics. So don't dismiss those problems. If you have any questions, just let me know.